Okay, lesson 17, the workbook. We're going to jot down here to the end. Alright, in the diagram, AB is secant to the circle at points A and P, and CB is secant to the circle at point CQ. The lines intersect at point B to form an angle with a measure of theta, which intercepts arc AC and arc PQ. If the measure of arc AC is 42x minus 1, the measure of arc PQ is equal to 65 degrees, and theta equals 10x, what is the value of theta? Okay, well, there's a few things that we know. We know that the angle that is given, theta, is the difference between its two arcs divided by 2. So we know that theta is equal to arc AC minus arc PQ, because those are the arcs that it intercepts, and it says it right there. So arc AC, arc PQ, and so now I'm just gonna, and it's half of that value. Alright, so now I'm going to use substitution and just replace what we know. We know theta is equal to 10x, so 10x is equal to 1/2 times AC is 42x minus 1 minus PQ, and PQ is 65. Now we're going to simplify. The first thing that I like to do is I like to get rid of any fractions. I like to make them 1, and I know that in order to make 1/2 1, we're going to multiply it by its reciprocal, which is 2 over 1, and we multiply both sides by it, so 2 over 1. So 2 over 1 is 2, and 2 times 10x is going to give us 20x equals 2 times 1/2 is just 1. 1 multiplied by anything does not change its value, and so that's why we did it. So then we're left with 1 times 42x minus 1 minus 65. Okay, so then we have 20x. 1 multiplied to anything does not change its value, so I'm not writing it again. So we have 42x minus 1 minus 65 is minus 66. Then I'm going to combine all of the like terms, and I'm going to subtract 42x to both sides, because since there wasn't a symbol in front of the 42, it's assumed to be positive. So 20x minus 42x is negative 22x. And that equals 42x minus 42x is 0, minus 66. Alright, so then we have negative 22x equals 0 minus 66 is still just negative 66. And then negative 22 is multiplying to x, so the inverse operation is to divide. So we're going to divide by negative 22, divide by negative 22. And negative 22 divided by negative 22 is 1 times x, and that equals negative 66 divided by negative 22 is 3. So x equals 3. Now the question was, what is the value of theta? So in order to find theta equals 10x, that was the information given. So now by substitution, we have theta equals 10 times 3, because we found that x was the value of 3. So 10 times 3 is 30. We'll go over there and check our work. All right. Great job. There we have it. Okay, question 8. In the diagram, line DA is tangent to the circle at point A, and line DB is secant to, that's a directed line statement, by the way, is secant to circle at point C and B. The rays intersect outside of the circle at point D to form an angle with a measure of 3x plus 15, which intercepts arc AB and AC. If the measure of arc AB is equal to 169 and the measure of arc AC equals 79, what is the value of x? Okay, so on this one we know that this angle is the difference, is half of the difference between its two intercepted arcs, and those are the intercepted arcs. So we know angle D is going to equal 1/2 of arc AB, the difference between its arcs AB and AC. So then we're going to set it up. The angle D is given that it is 3x plus 15, so we know angle D is 3x plus 15. That's going to equal 1/2 times the measure of arc B is 169 minus the arc AC, which is 79. And now we're going to simplify for x. Okay, this one I'm going to solve differently than the last one because the last one I had an x on the right hand side as well, and this one I only have an x on the left hand side. So I'm going to simplify the entire right side because it is all numbers. So I can go over here and click on a calculator, and I can click in parentheses 1 divided by 2, that's 1/2, times parentheses 169 minus 79. So again, I'm solving this one this way because it's all numbers. I can find what that value is because it is all numbers. So 1/2 of 169 minus 79 is 45. We have 3x plus 15. Now we're trying to solve for x. So then I am going to, since this 15 is being added, we're subtracting it to make 0 and move it to the other side. So then we have 3x. 15 minus 15 is 0. That was what we wanted to see there. 45 minus 15 is going to be 30. The reason why we wanted 0 was because 3x plus 0 is 3x, and that still equals 30. Now 3 is multiplying to x, so we're going to divide and make that value a 1. So 3 divided by 3 is 1 times by x, and 30 divided by 3 is 10. And so we're going back here. What is the value of x? Alright, well we have it. It is 10. And we're going to submit for grading before we move on. Good job. Alright, so now here we go. In the diagram, DG is tangent to the circle at point D. EF is secant to the same circle at point EF. The lines intersect outside of the circle at point G to form angle DGE, which has the measure of theta and intercepts arc DE and arc DF. Sol must prove that theta equals 1/2 the measure of arc DF minus the measure of arc ED. He draws in chord DE to visualize possible theorems or definitions to support his statements. Which theorems or definitions should Saul include in his plan for proof? Okay, so this is what I would do. In order to look through these, we have base angle, vertical angles, definition of isosceles, inscribed angle theorem, and exterior angle theorem. And I would scroll up to the proofs above because they have proven it already, and we want to find one that is drawn similar to what we have, which we had a point of tangency, we had a secant line, and then they drew in that chord. So now I'm looking through this. Okay, well, they had draw that chord, which he did, and then we have the triangle exterior angle sum, subtraction property of equality, inscribed angle theorem. If a tangent and a chord intersect on a circle at one point of tangency, then the measure of the angle formed is half the measure, substitution property, and the distributive property. So then let's scan right back down and look at that. They had as options base angle theorems. I don't recall that. They had inscribed and definition of isosceles. No, they had triangles, but not the isosceles triangles. I don't believe they had the vertical angles or the exterior angle. So let's check it, and if it's not, then we'll double check. Okay, some of the answers selected are incorrect. Okay, so try again. So that means to me that there's more than that. So let's scroll back and compare to our proof that was written out. It was okay, so the exterior angle sum, they dropped off the triangle. Inscribed angle theorem, and let's see if that's what we have. So we need the triangle exterior angle theorem. The exterior angle theorem. Submit for grading. Great job. So that's how I would go through and answer proof questions, is by going and finding one that is similar. So we looked at that one because it had a line that was tangent to it and a line that was secant to it, and they intersected on the outside. So that's why I used that one to compare, and they have everything that they used to prove it listed out. So in question 6, in the diagram, two secant lines BE and CD intersect inside of the circle at point Q, which is not in the center. They form angle DQE, which has a measure of 105 degrees. Angle DQE intercepts arc DE, which has a measure of 145 degrees. Its vertical angle, angle BQC, subtends arc BC, which has a measure of 6x minus 1. What is the value of x? Okay, well, we know that vertical angles have the exact same value. So we know then that BQC is 105. All right, so then we know, that that's helpful, but it doesn't tell us or set anything up for us to BC. But it is always nice to know that your vertical angles are congruent. They're the exact same value. We also know about vertical angles that they equal, so angle BQC is going to equal 1/2 of these two arc measures added together, the sum of it. So we're going to have 1/2 of arc DE plus the measure of arc BC. So now we're going to use substitution. So angle BQC, like we said, is its vertical angle, so we know that that value is 105. So we know that that value is 105. That equals 1/2 of the measure of arc DE is 145 plus the measure of arc BC is 6x minus 1, and then it's asking us to solve for the value of x. Okay, so now in order to solve this, I'm looking to find where x is, and x is right here. It is inside these parentheses, so the first thing I'm going to do is try and remove them, and it's being multiplied by 1/2, and I know in order to make 1/2 or a 1, it's to multiply it by 2/1, to multiply by its reciprocal. So we have 2/1. So 105 multiplied by 2, because 2/1 is 2, is going to be 210. That's going to equal 2 times 1/2 is just 1 times 145 plus 6x minus 1. Okay, well 1 times the value, 1 being distributed through 1 times the value of anything doesn't change that value, so that's why we did it. So then we have 145 plus 6x minus 1. Okay, now I'm going to collect all of my like terms. 145 and minus 1 is a like term, and that makes 144 plus 6x. We have 210 still. Since 144 does not have a sign in front of it, it's assumed to be positive. So in order to move it, we're going to subtract it. 144 minus 144. Alright, and 210 minus 144, 66. Alright, so we have 66 is equal to 144 minus 144 is 0 plus 6x. 0 plus 6x is 6x, which is what we want to get down to. And the last step, 6 is multiplying to x, and we want to make that a 1. So we're going to divide by 6. Divide by 6. 66 divided by 6 is 11. That equals 6 divided by 6 is 1x. So 11 is equal to the value of x. Let's scroll down. And double check. Great job. Now, the way I remember these inside or outside, how I remember when am I adding or when am I subtracting, is I ask myself, okay, is the angle they're giving me inside, or is the angle they're forming inside the circle or outside the circle? If it's inside, it's adding. If it's outside, we're subtracting. And then it's still 1/2 of either those arcs added or 1/2 of those arcs subtracted. So that's how I keep those in separate. Is it inside? If so, we're adding, and if it's outside, we're subtracting. Alright, here we go. In the diagram, two secant lines BE and CD intersect inside of the circle at point Q, which is not the center. Okay, so the reason why they're saying not the center is because if it was in the center, then it would be a central angle, and that is a different theorem. So they form angle CQE, which is labeled with a measure of theta and intercepts arc CE. Its vertical angle, angle BQD, intercepts arc BD. If the measure of arc CE is equal to 81 and the measure of arc BD is equal to 73, what is the value of theta? Alright, so they actually want us to find what this value is. Now I'm asking myself, is the angle on the inside and is it not in the center? Okay, so inside, not in the center, that means we're going to add them. So that means the angle theta is going to equal 1/2 of the arcs. So if you notice, angle theta projects onto this arc. This angle, its vertical angle, projects onto this arc. That's kind of how I just remember it. So it's arc CE plus arc BD, and they gave us that arc CE is equal to 81, so by substitution I'm just writing that in, and then arc BD is 73, so again by substitution. Now I'm looking at this, we already have theta all by itself on the left and we only have numbers on the right, so then I'm going to go over to Google and I'm going to type that in. 1/2 is 1 divided by 2 in parentheses, and then being multiplying to 81 plus 73, which comes out to be 77. So theta, the measure of our angle, is 77 degrees, which happens to be right there. So then we're going to check it before we move on, make sure we're not making a mistake, and great job. Alright, let's go on to angle 4. In the diagram, chords made by segment BE and segment DC intersect inside of the circle at point F, which is not the center. Angle BFD is labeled with a measure of theta and subtends arc BD. Angle BFD has a vertical angle, angle CFE, which subtends arc CE. A third chord, DE, is drawn in to create triangle DEF. Katie must prove that theta equals 1/2 the measure of arc BD plus the measure of arc CE. Which theorems or statements should Katie include in her plan for the proof? Okay, so let's look. They have the base angle, exterior angle, all radii of the same circle are congruent, inside angle theorem, vertical angles, and Pythagorean theorem. Let's go find the proof that is similar to this already. So it is inside the circle. So all of these angles that they're talking about are outside, so let's keep scrolling till we find one that is inside, like this. Okay, here we go. And here's the proof. So there's the arc addition postulate in the other correct plan. So then we have by the inscribed angle theorem, and then I am just scrolling through arc addition postulate. There's the semicircle, and then by theorem 4702. Okay, so then the other one was written out up here. So it says we have vertical angles, and then they would have the same congruent angle, and then we have that if two chords are secants, then it equals half of it. Okay. Here's the proof. Nope, that one's the secant one. Okay, so then let's go back here and let's remember that we had the triangle exterior angle theorem. We had a central angle is the same measure as its intercepted arc, substitution, and distributive property. And then they also gave us another proof that used inscribed angles, semicircles, and so let's check for that. So that's how I would recommend answering these. So they had inscribed angles and vertical angles. So let's check that. Alright, some of the answers selected are incorrect. Try again to increase your score. Okay, oh, we forgot the exterior angle theorem. So let's check that. Some of them are still not correct. Try to increase your score. We know that all radii of the same circles are congruent. I didn't see that in the theorem, but I was just scanning quickly. You have chosen the incorrect answers, so then let's not collect that one, and let's take off our vertical angle theorem, even though I feel like that should be part of it, just to check. Great job. Alright, so all you need is the inscribed angle theorem and the exterior angle theorem. I don't believe vertical angle theorem was even listed in its proof that we had scanned at. So then let's move on to, so that's how I would go about checking when it asks for a proof. Is scroll up, find the diagram that looks like the one that you're trying to prove. And for ours, it was this one, and there's the inscribed angle theorem. And if we scan through here, I'm sure there's not going to be anything about vertical angles, and there's not. So, and then the other proof that we had to compare it to was given wasn't that one, it was given right here. And right here it said the triangle exterior angle theorem. And yes, it does not have any vertical angles in there, so that's why it's not included. So anyways, there's some helps and tips for you